We'll solve some problems that involve simplifying a force in a couple moment system to a point. We'll solve these problems using a scalar analysis. Here's the basic idea. Say we had this force and couple moment system acting on this beam, and we want to simplify everything 2.0 over here with a single resultant force and a resultant couple moment. The way we go about it is we take all of the x components of the forces and we add them up to get the x component of the resultant force. That's shown right here. Then we do the same thing with the y components. We add all the y components up with the force system, and then that's equal to the resultant force component in the y direction. When we have these two components, we can find f sub r by Pythagorean's theorem, or really by vectorially adding these two components together. Finally, we can get the moment resultant that acts here by simply taking the moment of all of the forces in the system around point O and then adding to it the moment of the couples. And that's represented by this equation. Now realize that once we have our resultants, then when they're placed on the beam at this point O, the reactions on the beam here will be the same as they would be for this beam. Also, if I didn't have any supports that are holding the beam in place, then the way this beam would tumble in space would be the same as the way this one would move in space as well. So the systems are really equivalent. They cause the same external effects on each of the beams. Now we use these ideas and solve some problems. Let's begin with this problem. Here we want to simplify the force and couple moment system that you see on this member to an equivalent resultant force and couple moment acting at point O. Let me show you the member again with our unknowns. In other words, the unknown components of the resultant force and the unknown couple moment. I'm showing these all in the positive directions. If we get a negative answer for any one of them, it means the arrowhead goes the other way. We realize then that when these three unknowns have been calculated and are placed on the member at this point, the support reaction here will be the same as it will be over here when the entire system is acting on the member. Anyway, to get our answers, we have to apply the three key equations. First, we'll sum in the x direction. That means finding all the forces that act in the x direction on our system, and there's two of those. They go in the positive direction, so let me write it out. 100 plus 200. When you add them up, you get the result. It's 300 newtons. So that means that this is positive 300 newtons. It does go the way we see it. Now let's sum in the y direction. Looking at our member, there's only one force. That would be minus 400. Here it is again, and realize then that our arrow doesn't go up, rather it has to go down. Finally, we have to take moments around point O, and when we take moments around point O of, say, the 100 Newton force, is that going to be a plus or minus moment? Well, it'll be positive, won't it? Because if you find the perpendicular distance to its line of action, it's right here. It's 1 meter. And that moment tends to go this way, doesn't it? The thumb is directed out of the screen. So therefore, we write the first term as 100 times the moment arm of 1. What about the moment of the 400 Newton force? Is that plus or minus? Well, that'll be negative. It tends to rotate clockwise. So the thumb is directed inward. The moment of that, of course, is equal to minus 400 times 3. What about the moment of the 200? Well, it'd be 0, wouldn't it? Because it passes through point O. And finally, we have our couple moment. We have to add that to our result here. That moment is negative, isn't it? Remember, a couple moment is a free vector. It can act anywhere. And so we're simply moving it to point O. And when you work through the calculation, you get this result, minus 1,150 Newton meters. Essentially, the negative sign then means that the moment is not going to go in a counterclockwise direction, rather it goes clockwise. Finally, we can find our resultant force by adding the two components. Here's the vector addition. This one, of course, would be 300 newtons, and this one is minus 400. That's why I'm showing it going downward. Here's our resultant vector, which of course is 500 newtons from Pythagorean's theorem. All right, now let's solve this problem. Here we want to simplify this force system to an equivalent resultant force and couple moment acting at point O, right back here. So let's look at the member one more time with our resultants shown on it. To get our results, I'm going to take this force and I'll break it into its components, like this. Now we'll apply our equations and get our answers. So summing forces in the x direction, we have only two components. We have 200, and we also have 100 times 4/5. When you add these up, you get our result, and of course that's equal to 280 newtons. It's positive, and so indeed this arrow goes to the right. Now let's sum in the y direction. Looking at the join up here, we have two components again, this one and of course this one. So we write those out as minus 300 and minus 100 times 3/5. Therefore, this gives us an answer of minus 360 newtons. That means the arrow doesn't go up, it goes downward. Finally, we have to take moments around point O. So to do that, I'll start with the 300 Newton force. Will that create a positive or negative moment? It'll be negative, won't it? Because it rotates clockwise around O. Therefore, our first term is equal to minus 300 times our moment arm distance of 1 meter. Now let's move on and do the 200 Newton force. Does that create a plus or minus moment? It's negative because if you extend the line of action back to here, you'll see that the moment arm distance is 2, and that force tends to rotate this way, doesn't it? Negative. So we write it as minus 200 And the moment arm there, of course, is 2 meters. Now we'll have to deal with the two components of the 100 Newton force. We'll consider this one first. And that again is a negative moment. So we'll write it as minus 100. And our fraction is 4/5. And our moment arm for it is 2 meters. And finally, we have the moment of the vertical component. And that moment is negative also, isn't it? Minus 100 times 3/5. And our moment arm for that one is what? It'd be 3 meters. After all, if you brought it down to here, you'd see that distance is 3 meters. And when you work this through, you get your result. It's minus 1,040 Newton meters. Also, when you add these two vectors together, you get our resultant force, and it turns out to be 456 newtons, as shown here in the vector addition. And you would find this obviously from Pythagorean's theorem. All right, here's our final problem. We want to simplify the force system that acts on this member to an equivalent resultant force and couple moment at point O. And so again, we'll show the member with the three unknowns that we have to calculate, again, shown in the positive directions. Next, we'll break our forces into their components, like this, and of course like this, and now we can apply our equations. We sum forces in the x direction. We have the following. First, dealing with the 600 Newton force, the horizontal component is equal to what? You'd write that as 600 times the cosine of 60 degrees, wouldn't you? Now we have the component due to the 500 Newton force, and that of course is positive also. So we write this as plus 500, and there we write it times 4/5, 4/5. When you work this out, you get your answer of 700 newtons. Let's sum in the y direction. Considering the 600 Newton force, we have a plus or minus component. It's negative 600 times the sine of 60 degrees. And now we have the component of the 500 Newton force. It goes upward, and so therefore we write it as 500 times 3/5. When we figure this out, we get an answer of minus 219.6 newtons. It goes down instead of up. Finally, we have to take moments. So let's do that and finish the problem. We'll consider first the vertical component of the 600 Newton force. Is that going to create a plus or minus moment around O? It's negative, isn't it? Because it rotates this way around the point. Minus 600 times the sine of 60 degrees. And the moment arm for it is equal to 3 meters. Now we have the horizontal component. That also is a negative moment, isn't it? Because the moment arm for it is 2, and the moment tends to rotate this way, again, clockwise. So minus 600 times the cosine of 60 degrees. And our moment arm is 2 meters. There we go. Now let's deal with the horizontal component of the 500 Newton force. That moment is negative, and so it becomes minus 500 times our fraction, which of course is 4/5. And our moment arm distance for it is equal to 2 meters. Finally, we have one more component, this guy right up in here. Is that a plus or minus moment? That's positive because it tends to rotate this way. So our final component is plus 500 times 3/5. And the moment arm distance for it is equal to 3 meters. When you work all this out, you get your answer. It turns out to be minus 2.06 kilonewton meters. And so it doesn't go this way, it goes clockwise instead. And finally, if you want to find the resulting force, you have to add these two components, just like this, and get your resultant, 734 newtons. And so having completed our problem, we'll end our lesson.